Hello everyone! In this video, we are going to learn about discriminant. Let's firstly quickly recap the previous knowledge about the quadratic equation. So the quadratic equation is ax squared plus bx plus c equals to 0. To solve this equation, one method I have told before is to use quadratic formula. What is this formula? That is x equals to minus b plus minus square root of b squared minus 4ac over 2a. Right? I hope you can see there is a special thing in the formula. That is a square root. Have you ever thought what happened will be b squared minus 4ac less than 0? Because when we want to square root of a number, that number must be the positive or be the 0. Which means we should have b squared minus 4ac greater than and equal to 0. But what happened if b squared minus 4ac less than 0? Well, when we think about this, it is relevant to the number of the solutions. So, let me talk about for the quadratic function fx equals to ax squared plus bx plus c, b squared minus 4ac, that's what we will square root of, is called the discriminant. Why we want to know the discriminant? The value of the discriminant shows how many roots fx has. Then let us see if b squared minus 4ac greater than 0. fx has two distinct real numbers, real roots. Let's say roots. If b squared minus 4ac equals to 0, what has happened? Let's move to see the quadratic formula. If b squared minus 4ac equals to 0, so x equals to minus b over 2a. So we only have one root, which means if b squared minus 4ac equals to 0, fx has one repeated root. Now, what happened if b squared minus 4ac less than 0? But what we know is it must be greater than and equal to 0, square root of that. So, we don't have the real roots. Which means if b squared minus 4ac less than 0, fx has no real roots. You must remember that we are talking about real number. Always talk about the real numbers in the current study. And in the future study, you will learn about imaginary roots, imaginary number. So this part will be further discussed in the future. For this lesson, we only discuss about the real roots and real numbers. Well, when you see the function, it always think about the graph. So what will the graph look at if f(x) has two distinct real roots, or one repeated root, or no real roots? Let's see some graph. So first one, let's see if a greater than 0, which means we have the upper u, that is a small face. And when it is b squared minus 4ac greater than 0, so two distinct real roots, the graph look like that. Remember that the curve crosses x-axis, that points are the roots, right? So we have two roots, so which means the curve crosses 2 points at x-axis. For the b squared minus 4ac equals to 0, you have one repeated root, which means the curve only touch x-axis at 1 point, only 1 point. So how can the curve touch only once? It means the turning point, or we call that the minimum point of this curve, touch the x-axis. Now thinking about the b squared minus 4ac less than 0, which means the curve does not touch x-axis. It will look like that. So totally we don't touch it. How about a less than 0? Let's move this part away. Okay, if we say a less than 0, so we have the side face. Also, the b squared minus 4ac greater than 0, so we touch the x-axis twice. It will look like that, right? 2 points. And also for the b squared minus 4ac equals to 0, so only touch once, that is a turning point. And in here it's the maximum point. So only touch once. Turning point, that is the turning point. Let me write over here. Turning point. And when the b squared minus 4ac less than 0, so the graph looks like that. Totally, we don't touch the x-axis. Okay, now we have learned all the knowledge. For this lesson, we need to practice. So let's do some questions. Let's move a little bit. So for this question, the question asks to find the range of the values of x for which x squared plus 6x plus 2k equals to 0. And there are 3 parts, 3 questions. So first one, 2 distinct real roots. What we need to do first is to determine the a, b, c for the quadratic function. So a equals to 1, let me change the color, use the blue one to write the answer. So A equals to 1, B equals to 6, C equals to 2k. So to determine the number of the roots, we use the discriminant. Discriminant is b squared minus 4ac, that equals to 6 squared minus 4 times 1 times 2k. And what we have 36 minus 8k. Right? And then when the question asks you about that's the range of the values of k, and this equation has two distinct real roots, which means b squared minus 4ac greater than 0. So b squared minus 4ac greater than 0 implies that 36 minus 8k greater than 0. What we get 36 greater than greater than 8k. So k less than 36 over 8. So for all the real numbers k that less than 36 over 8, this equation has two distinct real roots. Now, the part B said that it has equal roots, which means it has one repeated root, so the discriminant equals to 0. b squared minus 4ac equals to 0 implies that 36 minus 8k equals to 0. So 36 equals to 8k, k equals to 36 over 8. That is when the equation has only one repeated root. Also, it has the equal roots. And part C, it said has no real roots, which means b squared minus 4ac less than 0. The discriminant less than 0 implies that 36 minus 8k less than 0 and 36 less than 8k. So k greater than 36 over 8. So for all the real values of k that is greater than 36 over 8, this equation has no real roots. Now move to the second question. The question said there is a function f(x) equals to x squared plus k plus 6 times x plus 3k, where k is a real constant. Part A, it asks to find the discriminant of f(x) in terms of k. So what we need to do, we need to define the value a, b, c for the function. So part A, the function that a equals to 1, that is a coefficient of x squared, and b is a coefficient of x, that equals to k plus 6. And c is a constant, that is 3k. Recall that discriminant is b squared minus 4ac. So we substitute the number into this expression. We get k plus 6 squared of that minus 4 times 1 times 3k. And then we do the calculation. That is k squared plus 12k plus 36 minus 12k. We have k squared plus 36. So that is a discriminant of f(x) in terms of k. And for part B, hence or otherwise, When you see in the exam, when you see hence or otherwise, it means you can use the previous answer. You can use the answer from the previous question. And it asks you to prove that fx has two distinct real roots for all values of k. So two distinct real roots, what does it imply? It implies that b squared minus 4ac greater than 0. So we want to prove b squared minus 4ac greater than 0 for all values of k. In the previous question, we get the answer that b squared minus 4ac, the discriminant, is k squared plus 36. So we want to prove that it's greater than 0. As you can see, for all values of k, k squared always greater than or equal to 0, which implies that k squared plus 36 greater than or equal to 36. It means that k squared plus 36 greater than 0. Be aware of that. It cannot equal to 0. If it equals to 0, it will have the one repeated root. So in here, you must write greater than 0. Don't add the equal. Thus, we can set that there are two distinct real roots for all values of k, since the discriminant k squared plus 36 greater than 0. That is the answer. Well, for the conclusion, it's just the knowledge over here. So we need to know what is the discriminant. That is b squared minus 4ac, and it works for the quadratic function. So the value of discriminant can be used to determine how many roots the function has. If the discriminant greater than 0, it has two distinct real roots. When equals to 0, one repeated root, and less than 0 has no real roots. And the graph are shown in here to identify whether the curve or the function has two distinct real roots, one repeated root, or no real roots. Now we finished here. Thank you for your watching. Hope you enjoy it. Thank you.